Now we will see the problem based on the concept we have learned. We have already learned the concept of silvered lens. Now we will see the problem based on that concept. The first problem I have picked from JEE 2006. A point object is placed at a distance of 20 cm from a thin plano convex lens of focal length 15 cm. If the plane surface AB is silvered, the image will be formed at. So first we will draw the plano convex lens. So this is our plano convex lens, and the problem says that its plane surface AB is silvered. So this is AB and it is silvered. Now, and the object is placed at a distance of 20 centimeters. So the object is placed at this point. So U is equal to 20 centimeter, and the focal length of this lens is 15 centimeter. We have to calculate the focal length of system. So the focal length of lens is 15 centimeter. So how we will solve this problem? First you will calculate the focal length of this system. So for this we just apply the concept we have learned in silvered lens, that is minus 1 by F equivalent is equal to twice by FL minus Fm, that is minus 2 by Rm, and afterwards we will calculate it by using sign convention also. After consideration of sign, now it is given as 1 by FL is equal to 1 by 15. So 1 by FL is equal to 1 by 15, and 1 by Fm, that is Rm, is equal to infinity. So minus 1 by F equivalent is equal to twice by 15 minus 2 by infinity. So from there we get 2 by 15, and 1 by F system is equal to minus 2 by 15. So the focal length of system will be minus 15 by 2. Now, so as the focal length comes with negative sign, then the system will behave as a concave mirror. So the system will behave as a concave mirror. So we may replace this system by a concave mirror of focal length 15 by 2. The object distance is given equal to 20 centimeter. So you have to apply the mirror formula. 1 by B plus 1 by U is equal to 1 by F, and 1 by V, U is minus 20. So 1 by minus 1 by 20, and F is equal to minus 15 by 2. So minus 2 by 15. From there we get 1 by V is equal to minus 2 by 15 plus 1 by 20. So minus 5 by 16, that is V is equal to minus 12. So negative sign of V says that the image will be formed on the side of object, that is image will be formed at the point I, and the distance of I from this mirror is equal to minus 12. So the image will be formed at 12 centimeter left of AB. So option C is correct. Now we will see second problem, and this problem I have picked from AIEEE 2004. A plane convex lens of refractive index 1.5 and radius of curvature 30 cm is silvered at the curved surface. Now this lens has been used to form the image of an object. At what distance from this lens an object be placed in order to have a real image of size of object? So the image should be formed is of real image, and the size of image will be the size of object. So clearly the object must be placed at the radius of curvature. So this is the, so the curved surface is silvered. So this will be the figure, and the curved surface will be silvered, and this is the equivalent mirror. So we will have to calculate the focal length of equivalent mirror, and the object must be placed into twice the focal length of equivalent mirror. So we will apply the formula. Minus 1 by F equivalent is equal to twice by FL minus 1 by FM, and 1 by FL is equal to mu minus 1 into 1 by R1 minus 1 by R2. Here mu is equal to 1.5. So mu minus 1 is 1 by 2. R1 is infinity and R2 comes with negative sign having value equal to 30 centimeters. So R2 is minus 30. From there we get 1 by 2 into 1 by 30, that is 1 by 60. So FL is equal to 60 centimeter. Now FM. So FM is equal to, or in fact minus 1 by FM is equal to minus 2 by RM, that is equal to minus 2 by minus R, and it is equal to 2 by R. R is equal to 30, so 1 by 15. So we get minus 1 by F equivalent is equal to 2 into 1 by 60 plus 1 by 15. So from there we get 30. So F equivalent is equal to minus 10. So clearly the focal length of this concave mirror will be 10. So the object must be placed at the radius of curvature, and the radius of curvature will be 20 centimeter. So in order to get a real image of the size of object, the object must be placed 20 centimeter from this pole, that is from the point of, from this center of this curved surface, from this pole of this curved surface. Now the next problem is an equiconvex lens of glass having refractive index 3 by 2, a focal length 10 centimeter is silvered on one side. It will behave like a, so basically you have to calculate that how it will behave. So this is equiconvex lens. As it is equiconvex lens, so the radius of curvature of both surfaces will be same, and the refractive index of this is 3 by 2. One surface of this equiconvex lens is silvered, and the focal length of this lens is f is equal to 10 centimeter. So you have to calculate that how this system will behave. So as the focal length is equal to 10 centimeter, then if you apply the lens maker's formula, then 1 by f is equal to mu minus 1 into 2 by r. And from there we get 1 by f, that is 1 by 10 is equal to mu minus 1, that is 3 by 2 minus 1 into 2 by r. And from there we get 1 by r is equal to 1 by 10 and r is equal to 10. So this is our equation 1, and you have to calculate the focal length of the system. So we have already learned that in case of convex mirror, if it is silvered at one side, then the focal length of the system is f is equal to, or f system is equal to minus r divided by twice into 2 mu minus 1. So we have already learned this formula. If you don't remember this formula, then you can derive this formula also here by using 1 minus 1 by f system is equal to 2 by fl minus 2 by rm. And from there f system is equal to minus r by 2 into 2 mu minus 1. So if I put the value, then f system is equal to minus 10 divided by 2 into 3 minus 1, that is minus 2.5. So clearly f system is equal to minus 2.5. So as the focal length of system comes with a negative sign, then clearly it's a concave mirror, and the option will be the concave mirror of focal length 2.5 centimeter. So answer C is correct. So now we will see problem number 4. A plano-convex lens, when silvered on the plane side, behaves like a concave mirror of focal length 60 cm. However, when silvered on convex side, it behaves like a concave mirror of focal length 20 cm. Then you have to calculate the refractive index of lens. So this is our plano-convex lens. And if we and if we silver on the plane side, then the focal length will be equal to 60 centimeters. So f is equal to 60 centimeter, and already we know that the formula in this case is equal to f equivalent or f system is equal to r divided by twice mu minus 1, while if we silver it on the convex side, then the focal length is equal to, we call it f1, and so focal length f2 is equal to r divided by twice mu, and this is f2 and it is given equal to 20 centimeter. So f1 and f2 are given, and from there you have to calculate the value of mu. So simply divide. So simply what you do, you just do f1 by f2, and from there you get 60 by 20 is equal to mu divided by mu minus 1, that is mu divided by mu minus 1 is equal to 3, and mu is equal to 3 mu minus 3. So from there we get 2 mu is equal to 3 and mu is equal to 3 by 2. So if you see the option, then option B is correct, that the refractive index of this plano-convex lens is 1.5. So all are easy problem. Now we will see some tricky problems. And this is the first problem of level 2. The radius of curvature of left and right surface of a concave lens are 10 and 15 centimeter respectively. The radius of curvature of mirror is 15 centimeter. Then you have to select the correct option between A, B, C and D. And you may note that here more than one option may be correct. Now this is a very good problem. If you see that we have air on one side, and if you see here, this is our one lens, so we call it lens L2, and this is our second lens, we call lens L2, and then this is the mirror, so we call it mirror M. So clearly if the light ray goes, then it refracts from this first lens L1, then it refracts, then it goes to the water lens and reflect from there. Afterward it hits the mirror and reflected from there. So after reflection it again refract from water surface and then from glass surface. If the all surfaces are denoted by R1, R2 and R3, then the light ray first refract from R1, then it refract from R2, afterwards it hits the mirror, that is R3, and then it reflects from R1, R2, then refract from R1. As the light ray refract twice from this lens L1, twice from this lens L2, and one time the mirror, so we write P system is equal to twice PL1 plus twice PL2 plus PM. And PL1 is equal to 1 by FL1, and it is mu minus 1 by R1 minus 1 by R2. So clearly R1 comes with negative sign, R2 comes with positive sign, and refractive index is 3 by 2. So 3 by 2 minus 1, 1 by 10 minus 10 minus 1 by 15. So from there we get 1 by 2 into so clearly the focal length of lens L1 is minus 12, that is FL1 is equal to minus 12. Now we will see the power of lens L2 or the focal length of water lens L2. So we write 1 by FL2 is equal to 4 by 3 minus 1 into 1 by 15 plus 1 by 15, that is equal to and 1 by FL2 is 2 by 45. So now we calculate PM. So PM is equal to minus 2 by RM, and RM comes with negative sign, so it's minus 2 divided by minus 15, that is 2 by 15. So clearly P system is equal to twice into 1 by FL1, that is minus 1 by 12, plus twice into 2 by 45 plus 2 by 15, and it is equal to minus 1 by 6 plus 4 by 45 plus 2 by 15. From there we get P system is equal to 5 by 90, and it is equal to minus 1 by F system. So clearly from there we get F system is equal to minus 90 by 5, that is equal to minus 18. So clearly the focal length of the system will be minus 18 centimeter, and as the focal length comes with negative sign, then the system must behave like a concave mirror. So this problem is also very much clear. From there we get P system is equal to 5 by 90, and it is equal to minus 1 by F system. So clearly from there we get F system is equal to minus 90 by 5, that is equal to minus 18. So clearly the focal length of the system will be minus 18 centimeter, and as the focal length comes with negative sign, then the system must behave like a concave mirror. So this problem is also very much clear. And this is also very good problem. The convex surface of a thin concavo convex lens of glass of refractive index 1.5 has a radius of curvature 20 centimeter. The concave surface has a radius of curvature 60 centimeter. The convex side is silvered and placed on the horizontal surface as shown in figure, where a pin should be placed on the axis so that image is formed at the same place. So here it is asked that where the pin should be placed so that image is formed at the same place. So image will formed at the object itself in case of mirror when the object is placed on the center of curvature. So basically we will calculate here the equivalent focal length of mirror, and we then place the object on the center of curvature of that mirror. In that scenario we will get image on the object. So clearly in this case minus 1 by F equivalent, suppose that we replace this by a mirror, then and if the focal length of that mirror is F equivalent, then minus 1 by F equivalent is equal to 2 by FL, where FL is the focal length of this concavo convex lens, minus 2 by RM. Now you just put this value, that you just first calculate the focal length of a concavo convex lens by using lens maker's formula. 1 by FL is equal to mu minus 1 by R1 minus 1 by R2, and the direction of incident light ray is taken to be positive, so this direction will be positive, and accordingly R1 and R2 both comes with negative sign. So this is our R1, this is our R2. So clearly mu is equal to 3 by 2, so 1 by 2 into minus 1 by 60 minus 20. So from there we get 1 by 2 into 1 by 20 minus 1 by 60, that is 1 by 2 into so focal length of lens is equal to 60 centimeter. Now if we calculate, if we apply the formula, then 1 by F equivalent is equal to 2 by 60 minus 2 by minus 20. So from there we get 1 by minus F equivalent is equal to 1 by 30 plus 1 by 10, and if we solve it, then we get F equivalent is equal to minus 30 by 4, that is equal to minus 15 by 2. So if we place the object at a distance 15 centimeter from the equivalent system, and then the image will be formed at the same place of object. So if you see the option, then option B is correct. And this is the part B of the previous problem. Like if the concave part is filled with water having refractive index 4 by 3, then find the distance to which pin should be moved so that image of pin again coincide with the pin. So earlier the pin was placed here and this distance was 15 centimeter. So this distance was 15 centimeter. Now suppose we have placed water in the concave part of this concavo-convex lens, then again we will have to calculate the equivalent focal length of this system. So the equivalent focal length of system will be given by minus 1 by F equivalent is equal to 2 by Fw plus 2 by Fl minus 2 by Rm, where Fw is the focal length of water lens. So 1 by Fw is equal to mu W minus 1, that is mu W minus 1, 1 by R1 minus 1 by R2. We will take this direction as a positive, then R1 will be infinity for this water lens and R2 is equal to minus 60. So from there we get 1 by Fw is equal to 4 by 3 minus 1, that is 1 by 3 into 1 by infinity minus 1 by minus 60. So from there we get 1 by 3 into 1 by 60, that is 1 by 180. So this is our equation 1, and again 1 by FL. So 1 by FL is equal to, we have already calculated the value of FL and it was 60. So 1 by FL is 1 by 60. Now we calculate the value of minus 2 by Rm. So it's equal to minus 2 divided by Rm comes with negative sign. So minus 20, that is 1 by 10. Now if we put all these things in this our equation A, we call it equation A, then minus 1 by F equivalent is equal to twice by 180 plus twice by 60 plus 1 by 10, and it is equal to 1 by 90 plus 1 by 30 plus 1 by 10. So on solving it we get  F equivalent is equal to minus 90 by 13, and from there we calculate the object distance O dash, that is if we consider this as a P, then P01 is equal to minus 90 by 30 into 2, as the object must be placed at the center of curvature of now new equivalent mirror. So this is our new equivalent mirror having focal length equal to minus 90 by 13. So it's equal to minus 180 by 13. So now you have to calculate O01. So to calculate O01, you just 15 minus 180 by 13. So from there we get 15 by 13, that is equal to 1.15 centimeter. So the object or the pin should be moved by a distance equal to 1.15 centimeter so that the image of pin will again coincide with the pin. A plane mirror is made of glass slab having refractive index 1.5 and thickness 2.5 cm and silvered on back. A point object is placed 5 cm in front of unsilvered face of the mirror. What will be the position of final image? So here the figure has already been drawn. If you see here, this is the glass slab and it has thickness 2.5 cm and its one surface is silvered. Now an object is placed 5 cm from its first face. Light ray first refract from this surface, that is surface ABC. Afterwards, it reflect from the surface, second surface, and then again reflect from first surface. So here the object is placed and it is 5 centimeter from the first surface. Now when it refracts from the first surface ABC, then the image I1 is formed. So we will first calculate this location of image I1, and for this we just apply the formula mu2 by B minus mu1 by U is equal to mu2 minus mu1 by R, where mu2 is the medium in which light ray is going, and mu1 is the medium from which light ray is going. U is the object distance, V is the image distance, and R is the radius of curvature of the surface. So basically, if you see here, the radius of curvature of this surface as it is plane is infinity. So we get mu2 by B minus mu1 by U is equal to mu2 minus mu1 by infinity, that is equal to 0. And from there we get mu2 by V is equal to mu1 by U, and V is equal to U mu2 divided by mu1. So this is basically our formula for refraction from the plane surface. So in this way we can calculate the value of V. So V is equal to U into mu2. U comes with negative sign. So minus 5, mu2 is 1.5 and mu2 is 1.5 and mu1 is equal to 1. So it comes equal to minus 7.5. So clearly the image distance is equal to I1 is equal to minus 7.5. So from it is on the left hand side and it's 7.5. So if you see the ray diagram also, then the light ray on entering in the denser surface moves towards the normal line, and in this way the image is formed at a distance more than the object distance from the first surface. So now if you consider the reflection from the second surface, so for reflection from second surface, so first we will calculate the object distance. So object distance is EI1, and it is EI1 is equal to 7.5 plus 2.5, that is 10 centimeter. So image distance will be EI2. So image will be formed at the point I2. So EI2 is our image distance for this reflection, and it is equal to 10 centimeter. Now we will again calculate the refraction from the first surface. So that is, we will calculate this line, and consequently the image will be formed at the point I3. So again we will apply the formula, and our formula is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Here R is again infinity, so we get the second term is equal to 0, and from there we get mu2 by V minus mu1 by U is equal to 0, and from there we get V is equal to U mu2 by mu1. So here if you see here, for the surface ABC, so for ABC surface, mu2 is equal to air, as the light ray is going to air from the glass medium. So mu1 is equal to 1.5. So what will be the value of U for the third refraction? So for third refraction, that is for the refraction from the surface ABC, we will get U is equal to BI2, and BI2 is equal to 2.5 plus EI2, that is 2.5 plus 10, and it is 12.5. So if we consider refraction from the third surface, then we get V is equal to U, that is 12.5. I will just first write the formula. V is equal to U into mu2 by mu1, and here mu2 is equal to 1. So we get 12.5 into 1, and mu1 is 3 by 2. So from there we get 25 by 3, that is equal to 8.33. So we get the image formed is 8.33 from the unsilvered face. So if you see the option, then the answer D is correct, 8.33 centimeter from unsilvered face.